Dr. Ramanuja, Associate Professor, Department of Mathematics, Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad. In previous modules, I discussed about Rolle's theorem as well as Lagrange's theorem, Cauchy's mean value theorem, and also expansions of the function using Taylor series as well as the Maclaurin series. Further, this course I extended in the previous classes about the special functions, which is beta and gamma function. Further, I am going to extend some example problem and also review about their properties in the beta function. In the present, I am in the module of beta and gamma function. This is module 3.5. Further, I am extending this topic. For this course, I am referring the textbooks like Higher Engineering Mathematics by B.S. Gravel and J.C. Jain, and also some parts I referred as a S-Chan textbook also. Let me talk about the definition of beta function once again. What is the definition of the beta function? What are the properties of the beta function? And also further I am going to explain about the gamma function and their respect to their function properties also. Let us take the beta function. I discussed about the beta function. Beta function is an Eulerian integral of the first kind, which is an improper integral. I discussed about the improper integrals also. Improper integrals, which is an unbounded functions, Further, we classified into first kind of the improper integral and second kind of the improper integral. Let us talk about the beta function. Beta function is a two-variable function, and which is represented by beta of m comma n. Beta of m comma n is equal to integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 into dx. Here, this beta function, the beta function is a function of two numbers. Let us look this beta value. Beta value, it depends upon the values of m as well as n. That's what we say, that the function of two variables. For this two variable, I explained about the how the beta function existed in the previous lecture. Integral 0 to 1 into x power m minus 1 into 1 minus x whole power n minus 1 into dx. That's what this beta value depends upon the values of m and n. This beta m and n value is always greater than 0. This is about the definition of beta function. Further, I am extending single variable function, which is called as a gamma function. Gamma function can be represented by gamma of n equal to integral 0 to infinity e power minus x power n minus 1 into dx, where n is always greater than 0. This is called as the gamma function. Okay. Gamma function, what is a gamma function? Gamma of n is equal to integral 0 to infinity e power minus x power n minus 1 into dx. This gamma, the symbol representation of the gamma function, gamma is a function of n. Gamma function of n, which is called as a gamma n. Further, let us talk about some properties of beta function and also properties of gamma function. See the properties. Already I discussed about the properties. First property, which is called a symmetric property of the beta function. Look, the beta function. Beta is a function of m comma n. I can rewrite beta of n comma m. This is called a symmetric property of the beta function. We can interchange m values. We can interchange n values also. And the second property is called as the integral property of the beta function. Beta of m comma n equal to integral 0 to infinity x power n minus 1 by 1 plus x whole power m plus n into dx. I can rewrite in terms of n, I can use as an m. Integral 0 to infinity x power m minus 1 by 1 plus x whole power m plus n into dx. This is called as the integral form of the beta function. I can rewrite the beta function in terms of the trigonometric function beta of m comma n equal to 2 into integral 0 to pi by 2 sin theta whole power 2m minus 1 cos theta whole power 2n minus 1 into d theta. This is called as the beta function. We can rewrite in terms of trigonometric value. And also beta function, further we extend one more property, beta of m comma n equal to m plus 1 comma n, beta of m comma n plus 1. This also the fourth property of the beta function. And also further we need to calculate beta value. Sometimes it may depends upon the gamma values also. Therefore, I am going to extend the properties. Like a next property, I can say this is an gamma of 1 equal to 1, and also gamma of n plus 1 can be written as gamma of n plus 1 can be written as n into gamma n, or I can retain gamma of n equal to n plus 1 by n, I can say. And one more property, gamma of 1 by 2 equal to root pi. These are the basic property. Further, we can express, if you want to prove these results. In the previous lecture, I explained how to prove this result. If you take the definition of gamma function, substitute n equal to 1, we will get the gamma of 1 equal to 1 by 2. Similarly, gamma of 1 by 2 equal to root pi. Suppose sometimes I can express gamma of n equal to n minus 1 into gamma of n minus 1. Further, this can be extended into n factorial values also, extended into n factorial values. Okay, let me calculate some gamma values, where the gamma values are undefined values also I discussed in the previous classes. Okay, we need to compute in the problem 1, I can say compute the value of gamma of 5 by 2. See, gamma n value, how much I am going to take? N value equal to 5 by 2. Can I write like this definition? Gamma of n can be written as n minus 1 into gamma of n minus 1. Further, this can be extended, gamma of n equal to n minus 1 into n minus 2 into gamma of n minus 2. Further, I can extend like this result. Okay, let us take, we need to compute the value of gamma of 5 by 2. How do you write gamma of 5 by 2? 5 by 2 minus 1 into gamma of 5 by 2 minus 1. If I simplify this result, this becomes 3 by 2 into gamma of 3 by 2. Similarly, I need to calculate gamma of 3 by 2. Therefore, 3 by 2 into, how can I write this one? 3 by 2 minus 1 gamma of 3 by 2 minus 1. Therefore, 3 by 2 into, if I simplify this result becomes 1 by 2 gamma of 1 by 2. We know already gamma of 1 by 2 equal to root pi. Therefore, 3 by 2 into 1 by 2 into root pi. Therefore, 3 root pi by 4. This is the way to compute the values about the gamma. We can calculate similar procedure. We can find like this. We calculate what you call gamma of 7 by 2. I can calculate gamma of 11 by 2. Like this, we can calculate the gamma, whatever the related to the gamma functions. Let us talk about the gamma of, even though it is a negative. How do you calculate the gamma of negative? Let us look the where the gamma functions are undefined, then only we can say such a values we need to calculate. Like look this property. If you look this property, gamma of n equal to gamma of n plus 1 by n. This is the, see, in this case you must understand what is the how to define this a rational function. This is a rational function. For this rational function, we can't define n is not equal to 0. N is not equal to 0. But we can define for the negative integers. Minus 1, minus 2, etc. we can define. Okay. Let us use this property, gamma of, for second problem, gamma of n is equal to gamma of n plus 1 whole divided by n. For this case, I can substitute n equal to minus 1 by 2. Put n equal to minus 1 by 2. Therefore, gamma of minus 1 by 2, gamma of minus 1 by 2 plus 1 divided by minus 1 by 2. See, this becomes gamma of minus 1 by 2 minus, this becomes minus 2 reciprocal gamma of 1 by 2. Gamma of minus 1 by 2 equal to minus 2 into root pi. Already we know gamma of minus 1 by 2, which is equal to minus 2 into root pi. This is the gamma of minus 1 by 2 value. And similarly, we can compute gamma of minus 3 by 2. Let's take the property of gamma of n is equal to gamma of n plus 1 divided by n. Now, I need to substitute n value minus 3 by 2. This becomes gamma of minus 3 by 2, gamma of minus 3 by 2 plus 1 whole divided by minus 3 by 2. If I simplify this result, minus 3 by 2, which is minus 2 by 3 into gamma of, if I take this one, gamma of minus 1 by 2. Therefore, gamma of minus 3 by 2 equal to minus 2 by 3 into, what is gamma of minus 1 by 2? Minus 2 root pi. I am using the previous result. Therefore, this becomes 4 root pi by 3. This is the gamma of minus 3 by 2. Similar value, similar manner, we can calculate gamma of 5 by 2, gamma of 7 by 2. Like this, we need to compute all the values by using gamma property definition. And further, I am extending this topic. There is a important concept behind to, because when we need to calculate beta values, even though integer value we can extend directly, but even though n values are not an integer value, is a fractional value, in such a cases we need to convert the beta function in terms into gamma function. That's what we say, that there is a relation. The relation is called, here there is a relation between beta and gamma. Okay, let me talk about the definition of relation between beta and gamma. Again, I am going to use this relation, beta value, I can convert all gamma values, I can compute all gamma values, how previous we solved the computed values. Here, there is a beta, the relation between beta and gamma. There is a relation between beta and gamma. Beta of m comma n equal to gamma m, gamma n divided by gamma of m plus n. This is an important result whenever we need to convert the beta function into, I can say simply, two variable function can be converted into single variable functions. This is a relation between beta and gamma. Okay, what is a beta relation between beta and gamma? Beta of m comma n equal to gamma m, gamma n divided by gamma of m plus n. Okay, this is a relation. Coming 3.56 module, I am going to prove this result. Okay, let me take the related to the problem. There is an improper integral. I can express this integral value in terms of beta as well as in terms of gamma. Okay, express the integral beta and gamma. There is a integral values are given. I am going to extend this function, this integral value into beta as well as gamma. What is the given question? Let me write the question. We need to express beta as well as gamma. Integral 0 to 1 x by square root of 1 minus x square into dx. See, there is a denominator value. The denominator value here is given as a square. I can give cube. I can take 5, I can take 7, I can take 8, whatever the values of x by under root, whatever the values, we need to express always first beta, then beta is converted in terms of gamma. Okay, let me see whenever we look the integral values, integral 0 to 1. If I say integral 0 to 1, maybe this function is maybe an beta function. Okay, how do you write this integral value? X into 1 minus x square whole power minus 1 by 2 into dx. Say, taken denominator into numerator, this becomes a negative sign. Here, this is a beta function. The definition of beta you can understand. Beta of m comma n equal to integral 0 to 1 x power m minus 1 into 1 minus x. Are you observing now? 1 minus x whole power n minus 1 into dx. Now, what we will do, there is a square, there is a cube, there is a power 4, whatever the values there, we need to convert into what? Single degree equation, single degree function. Let's take put, I am going to substitute x square equal to y. I can assume as it is also. X is equal to y power 1 by 2. If I make the derivative, difference of this function dx is equal to 1 by 2 into y power 1 by 2 minus 1 into dy. Dx is equal to 1 by 2 into y power minus 1 by 2 into dy. This is the value of dx. Now I am going to substitute all the values in this integral value. Okay, let me talk about the integration. See, in the question, x equal to 0 to x is equal to 1. But now what we will do? We are transforming x to y. Therefore, if I substitute x equal to 0, here 0 square, y value becomes what? 0. Similarly, x limit, upper limit 1, I can substitute 1 square. 1 square becomes what? 1. Y value is how much? 1. In this way, we need to transform the limits. X limit changes to y limit now. Now look this x is replaced by how much? Y power 1 by 2 into 1 minus x square is there. What is x square? I can replace by what? Y whole power minus 1 by 2 dx. What is dx? 1 by 2 y power minus 1 by 2 into dy. Okay, I substituted all the transformations. Integral 0 to 1. Now 1 by 2 is a constant. Therefore, y power 1 by 2, y power minus 1 by 2, if we add bases are the same, powers are added, then the resultant value becomes 0 into 1 minus y whole power minus 1 by 2 into dy. Now I can compare. Now this looks like a beta function, but now we need to compare. Here there is a x, here there is a y, where whatever the x or y or t, whatever the values, we need to compare what? Powers. Okay, y power 0 is there. What is x power? M minus 1. M minus 1 equal to 0. M equal to how much I got? 1. And similarly, what is 1 minus x whole power? How much? N minus 1. I can compare minus 1 by 2. Therefore, n equal to minus 1 by 2 plus 1, n equal to plus 1 by 2. I got m value as well as n value. Now, I am going to transform this integral value in terms of beta 1 by 2 into beta of what is m value? 1, n value is 1 by 2. Now, this integral beta value, now I express this integral in terms of what? Beta. For this beta, I need to transform what? In terms of gamma. Are you observing? Already I told the relation. What is the relation? Beta m comma n can be expressed in terms of gamma m, gamma n divided by gamma of m plus n. Therefore, 1 by 2 into m value. What is m value? Gamma of 1 into gamma of 1 by 2 whole divided by gamma of 1 plus 1 by 2. Therefore, 1 by 2 into gamma of 1, already you know the property, gamma of 1 is 1 into gamma of 1 by 2 root pi whole divided by, this becomes gamma of 3 by 2. This is nothing but root pi by 2 into 1 by gamma of 3 by 2. How do you write gamma of 3 by 2? Already I computed the previous values. How do you calculate gamma of 5 by 2? How I calculate? How do you write this one? 3 by 2 minus 1, which is nothing but 1 by 2. Remaining is gamma of 1 by 2. What is gamma of 1 by 2? Root pi. Now root pi, gamma gets cancelled. The resultant value becomes 1. I hope now whatever the integral value we transformed into beta as well as beta to gamma. They using what? Using the relation between beta and gamma. Let us compute example 2. There is an integral. This is also an important concept behind these integral values. Integral 0 to infinity e power minus x square into dx. How do you compute this value? See, whenever we are looking the integral, we must observe the limits also. Because when we observe the limit, at least the function, how can we convert this integral? Okay. Let us take this example Example 2, we need to evaluate integral 0 to infinity e power minus x square into dx. Whenever if you look the integral limit, upper limit, okay, this looks like a gamma function. But what is the definition of gamma function? First of all, gamma n equal to integral 0 to infinity e power minus x power n minus 1 into dx. See, whenever you are observing the definition of gamma, e power, what is e power? Minus x. It should not be any in powers, maybe cube, maybe 2x. Such a functions we are going to transform into single degree functions. Now I need to convert x square into linear form. Put x square is replaced by t or y, we take any variable. Now x becomes t power 1 by 2. dx is equal to 1 by 2 into t power 1 by 2 minus 1. dx is equal to 1 by 2 into t power minus 1 by 2 into dt. Now this integral becomes integral e power minus x square. X square replaced by what? X square is replaced by t, and also dx is replaced by 1 by 2 t power minus 1 by 2 into dt. Now look the limits. The question limits x is 0. X is how much? Infinity. Suppose x value I can substitute here 0 square. What is 0 square? Is 0. What is t value becomes in this case? 0. T is infinity, here is t square, x square is infinity, then t becomes what? Also infinity. Now the limits are transformed to in terms of t values. Okay, let me take the constant as a common 1 by 2 integral 0 to infinity e power minus t power minus 1 by 2 into dt. Now this function is a gamma function. Let's go with the definition of gamma. Gamma of n equal to integral 0 to infinity e power minus x power n minus 1 into dx. Now e power minus t, we converted into the single degree function now, e power. Then the remaining term is what here? T power minus 1 by 2 is there. What is x power here? N minus 1. Now you can compare n minus 1 is equal to minus 1 by 2, n equal to minus 1 by 2 plus 1, n equal to 1 by 2. What is n value? 1 by 2. This entire integral value we converted into the gamma of 1 by 2. Already we know the gamma of 1 by 2 root pi by 2. Okay, this is the property of the gamma function. See, this integral, I am extending one more property for this integral value. Let us take the integral maybe minus infinity to plus infinity e power x square into dx. I need to convert this where from minus infinity to plus infinity. Here there is a value x square. Already you know x square is an even function. Whenever there is a limit, when you see the limits, you must understand minus a to plus a. Therefore the integral varies from minus infinity to plus infinity. X square is an even function. Therefore I can rewrite 2 into 0 to infinity e power minus x square into dx. What is this integral value? Already we proved this entire value becomes 2 into what is integral 0 to infinity? Root pi by 2. Gets cancelled. This becomes what? Root pi. We can calculate not only this integral, you must remember the integral 0 to infinity e power minus x square into dx. This is also an energy function in the parabolic path. When you draw the function in terms of graphical representation, there will be energy bounded by between 0 to infinity. Suppose you can extend like this integral values in the powers of what? X cube. We can calculate x power 4, x power 5. Like this, whatever the improper integral, second kind of the improper integral, we can evaluate similar procedure. Okay. Further, I am going to extend one more problem, evaluate integral 0 to infinity x square x power 6 into e power minus 2x into dx. When you observe the limit, this is also similar to the special kind of second function, which is Eulerian second integral, improper integral. Integral 0 to infinity x power 6 into e power minus 2x into dx. Already I told the definition of gamma of n. What is definition of gamma of n? Integral 0 to infinity e power minus x power n minus 1 into dx. Now I think you are observing there will be, it should be what? Single variable. It should not be any multiple of numbers. Then only we can convert this integral in terms into gamma function. Let us take here minus 2x, let us take 2x is equal to t. Let us assume put 2x equal to t. Therefore, d2 into dx is equal to what? dt. dx is equal to dt by 2. Now I am going to substitute in this integral values. Integral x, we need to calculate what? There will be x value. How do you write x value? X is equal to t by 2. Wherever x is there, I can replace by t by 2. Now what happens? This value becomes t by 2. X, I replaced x power is what? 6 into e power minus 2x. 2x is replaced by what? T. And dx is replaced by dt by 2. Look this limits. X limit, what is x limit now? 0. What is the upper limit? Infinity. If I substitute here, x is 0, here 2 times of 0, then t limits also becomes 0. Similarly, if I substitute t equal to infinity into times 2, the resultant value is also what? Infinity. Okay, now you got about the limits of this integral. And if I simplify this value, this becomes 2 power 6 and here it is 2, 1 by 2 power 7 integral 0 to infinity e power minus t power 6 into dt. This entire integral value now looks like a gamma function. Now go through the gamma function definition from here. E power minus t, e power minus x, t power 6, x power n minus 1. Now I am going to compare n minus 1 equal to 6, n equal to 6 plus 1, n equal to 7. N value is how much? 7. Now this entire integral value, I can convert into gamma of 7. Okay. How do you evaluate gamma of 7 value? How do you evaluate? 1 by 2 power 7 into gamma of 7 can be written as 6 factorial. Further, we can simplify this result. Okay, you will get the value of this integral value. See, in this procedure, we can evaluate whatever the integral values of x power 6 or 7 or 8 or any e power minus 2x or minus 4x. Similar procedure, we can evaluate such a improper integrals. See, further, I am extending into a trigonometric function. One more problem. Here, to evaluate integral 0 to pi by 2 sine power 7 theta into d theta. See here, already this function we can evaluate by using the reduction formulas. Okay, we know already reduction formulas. Integral 0 to pi by 2 into sine power n theta into d theta. Therefore, n minus 1 by n, n minus 2 by n minus 1, so on. It depends upon n is an even value or n equal to odd. Therefore, it is 1 by 2 into pi by 2. If it is an odd, 3 by 2 into 1. In this manner, we can expand the reduction formula. But for in this case, we are applying beta functions to evaluate some extensions of the problem. Suppose here power is an odd number. If there is some fractionals also possibilities, because when we solving some engineering problem, whenever we take integral 0 to pi by 2 whole sine power 7 by 2 into theta into d theta. In such a cases, we are not going to extend that values in terms of reduction formulas. In such a cases, we are extending, first of all, the function integral value can extend in terms of what? Beta function. Further, we need to calculate the value. That value we need to convert beta into gamma functions. Let us take this example problem. Integral 0 to pi by 2 sine power 7 theta into d theta. I can rewrite integral 0 to pi by 2 sine power 7 theta cos power 0 theta d theta. Already you know the beta function in terms of trigonometric form. What is the integral 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta equal to 1 by 2 into beta of m comma n. What we converted in terms of what? Beta. This integral value, I am going to compare integral 0 to pi by 2 is the same. What is sine power 2m minus 1? What is 2m minus 1? 2m minus 1 equal to 7, 2m equal to 7 plus 1, 2m equal to 8, m equal to 4. Similarly, 2n minus 1 equal to 0, 2n equal to 1, therefore n equal to 1 by 2. You got m as well as n. Now, I can transform this integral value. Into what? 1 by 2. 1 by 2 beta of what? Beta of m comma n. What is m? M is 4, n is 1 by 2. Now, I need to convert this beta value in terms of gamma. Okay, how do you write the relation between beta and gamma? Beta of m comma n is equal to gamma n whole divided by gamma of m plus n. Therefore, gamma of 4, gamma of 1 by 2 whole divided by gamma of 4 plus 1 by 2. 1 by 2 into gamma of 4. How do you write gamma of 4? 3 factorial into gamma of 1 by 2 root pi whole divided by 4 times 8, 8 plus 1, 9, gamma of 9 by 2. How do you evaluate this one? 1 by 2 into 3 factorial into root pi whole divided by gamma of 9 by 2. Already I computed gamma of 5 by 2. Similar procedure, I can calculate gamma of 9 by 2. How do you write gamma of 9 by 2? 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2. When there is a 1 by 2, which is gamma of 1 by 2, gamma of 1 by 2, which is equal to root pi. Now, root pi gets cancelled. How do you write this one? 3 factorial. 3 factorial means 3, 2, 1. 3 factorial can be written as 3, 2, 1 whole divided by 2 into 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2. 2 gets cancelled. If I simplify this result, you will get the integral value. You can use your calculator and you can calculate. Similar procedure, I am extending in terms of what? Cos power 4 theta. To evaluate, we can take, this is a integer, even integer. We can use directly by using into reduction formulas, but we are converting in terms of what? Beta as well as gamma functions. Okay, what is the integral value? Integral 0 to pi by 2 cos power 4 theta d theta. How do you write this integral value? Integral 0 to pi by 2 sin theta power 0 cos theta power 4 theta into d theta. Already we know the relation between beta gamma in terms of trigonometric functions. Integral 0 to pi by 2 integral 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. Now I am going to compare the integral values, trigonometric power values. 2m minus 1 equal to 2m minus 1 equal to 0, 2m equal to 1, m equal to 1 by 2. Similar procedure, 2n minus 1 equal to 4, 2n equal to 4 plus 1, 2n is equal to 5, n equal to 5 by 2. We got m as well as n value. Now I am converting this entire integral value into 1 by 2 into beta of m. M how much I got? 1 by 2 into n value, which is 5 by 2. Now I can say this integral I can express first beta, then further I am extending into the gamma functions. Now already we know the relation between beta and gamma, gamma m, gamma n whole divided by gamma of m plus n. Therefore, 1 by 2 into gamma of 1 by 2, gamma of 5 by 2 whole divided by gamma of 1 by 2 plus 5 by 2. Therefore, 1 by 2 into gamma of 1 by 2, which is root pi. How do you calculate the gamma of 5 by 2? What is gamma of 5 by 2? 3 by 2 into 1 by 2 root pi whole divided by, if I take LCM for the denominator as a 2, it becomes 1 plus 5. This becomes 6. 6 divided by 2, which is 3. Therefore, 1 by 2 into 1 by 2 into root pi, which is pi, 3 pi by 4 whole divided by, this becomes how much? This becomes 3, which is 1 by 2 into 3 pi by 4 into 1 by 3, okay, which is 3 pi by 12, 24. We can calculate the integral value. First we need to convert into first beta. Beta can be converted into the gamma values. Okay. I hope now you familiarized by the properties. We can convert whatever the integrals into gamma as well as beta functions. I hope now you understood all the properties and basic problem. Further, I am going to prove the next module. I am going to prove the relation between beta and gamma and some more example problems. I hope now you understood. Thank you.